Problem number 6 from the review part 3 for the final exam of honors algebra 2. We have a problem. Okay, so I need a volunteer. No, thank you.
According to the American Pet Products Manufacturers Association, 2003-2004 National Pet Owners surveyed 30% of U.S. households own at least one dog, and 34% of U.S. households own at least one cat. Assume that 60% of U.S. households own a cat or a dog.
Huh? Yeah, please.
A. What is the probability that a random U.S. household owns neither a cat or a dog? What is the probability that a randomly selected U.S. household owns both a cat and a dog? What is the probability that a randomly selected U.S. household owns a cat if the household has a dog?
Thank you so much. So what is the meaning? Because it says here, 39% of U.S. households own at least one dog, and 34% own at least one cat. What is the meaning of at least?
So one or the other?
One or more.
One or more. At least means one or more, right?
Yeah.
And if it says no at least, that doesn't happen, that means that person doesn't have any cat or any dog. No cats, no dogs. Okay? Okay. So let's try to do the diagram. When you have these kind of problems and the answer is only one, I mean the question is only one, it's okay, you can proceed as well any way you want. But if I have 3 or 4 questions about the same situation, it's always important to create a table, to create a diagram, or to create something that you can see the whole picture. Because what happens is sometimes you're solving the first part, and that answer for the first part, you're going to use it for the last part. So it's important to know what are you getting and where everything is located at, so you can use it and you spend less time solving that problem. And it's even easier for you to understand. So in this case, we're talking about people who has at least one cat, or other set of people who has at least one dog. But they're not telling us that these two are mutually exclusive. So it's very easy to think that in this group of people, there'll be maybe one or more that have both a cat and a dog. So if you are creating those diagrams, it's actually called Venn diagrams. So let's say this is the set of people who has the cat, at least one cat. And this one is another set of people who has at least one dog. Okay? Well, the reason why I'm intersecting these two sets is because it's possible to have one in the middle, at least, right? They don't tell us this is exclusive, so we cannot assume that. Also, the whole population, this is the union of these two. This is something that is given. Assume that 60% they own a cat or a dog. That means union. That means these two together, 60% of them have a cat or a dog. And that's the union of it. But out of the whole population, the whole set, let's say, is this one. There is people that don't have no cats, no dogs. So what would be the percent of that? If 60% have at least one cat or at least one dog, then 40%, the rest of it don't have any, right? This belongs to that one. So 100%, this is it. Okay? Now what they are telling us? They tell us that 68%, no, 39%, they have at least one cat. And 34 at least one dog. So 39% is here, including this part. right? Including the intersection part. And all this, including the intersection part is 34. So we need to know how much is in the middle. Okay? So we're going to use a formula that we did in class, we went through in class. It's the probability of A or B of the union. Probability of C or D is going to be the probability of C. Who remembers this? Who remembers the formula for this? Probability of C plus probability of D. What else? Minus the probability of C and D. And that is the one is in the middle. This one is in the middle. So we know this one is given. We know this two because they're given as well. So the only one we don't know is the end. And we're going to isolate it from here. So we have then probability of C or D is 60%, 0.60. Equals probability of C, it was 0.39. Plus probability of D, which dog is 0.34. Minus the probability in C and D that we don't know what it is. And that's exactly what we want. Find that. So from here, I just had to isolate it. Imagine this is X. Like this is X. And we're looking for it. How much X is, okay? So add these two. These two together give us 73.73. 0.60 is equals to 0.73 minus X. Then subtract 0.73. Subtract. And you have negative 0.13 equals to negative X divided by negative 1 in both parts. X equals to positive 0.13. There is no negative probability. So it's 0.13. That means right here you have the probability of having a cat and a dog is 13% or 0.13. Right? That means I can find out how much this is without the intersection. Because the probability of having at least one cat is 0.39. Subtract 0.13 to see how much is here. So 0.39 minus 0.13, it gives us 0.21. Because these two together is 0.34. See it? Probability of having at least one dog is 0.39 minus 0.13 give us 0.26. 0.26. I think with this one we're ready to find out 0.60 and 0.40. Putting all of them as a decimal. You don't have to go, just to be consistent, okay? The first question was, what is the probability that a randomly selected U.S. household owns neither a cat nor a dog? 40%, which is 0.4, right? This one here. So, part A, probability of no cat, dog is 0.40. Part B, see, we have everything in the diagram. What about part B? What is the probability that randomly selected U.S. household owns both a cat and a dog? And 0.13. Probability of cat and a dog is exactly the intersection of these two sets. The probability of that happens is 0.13. Probability of cat and dog is 0.13. And the last one, probability the randomly selected U.S. household owns a cat if the household has a dog. So it's probability of A given B. We went through that as well in class. Probability in this case, cat given dog, right? At least one cat given it has a dog. The formula for this is the probability of these two happens, C and D, divided by the probability of the bottom one, which is D. Probability of C and D over the probability of D. And we have these numbers already in the diagram. C and D, we say is 0.13 over probability of dog was given is 0.39. This is 1/3.